States or North America area. Okay, without further ado, I'm going to jump into the live demo. The first topic I'm going to cover is about the point feature extraction. I'll try to show you how to create or import an existing feature code library and how to use that feature code library to extract features such as trees or poles or some other point features. So as you can see, here is the familiar TBC UI. I have specifically realigned this plan view and 3D view horizontally so that I can see both sides very easily. If you haven't tried this before, you can hold your left mouse button and drag your window until you see some dash frame showing up. Then you can realign all your windows properly. The first thing I want to mention is, as you can tell from the point cloud color, I have classified this point cloud into different regions, such as buildings and ground and vegetation. This whole process is automatic, so there's nothing much I could tell, but everything we are going to do from here will be based on the classified point cloud. It's not necessary to classify the point cloud, but we definitely see it helps to hide some unnecessary point cloud and speed up the performance. All right, so the next thing I'm going to show you is the most important idea in TBC probably for surveyors, feature code library. Usually we can just use the project settings and go to the feature code processing tab and navigate to the default global features FXL, which always ship with TBC. And also, since we are dragging and dropping all other TBC file formats, we can also do the same thing, drag and drop an FXL into TBC. If you haven't used the feature code library before, this is the structure of this library. We have all the feature codes sitting in different categories. For example, under this earth category, we have a feature code for broadleaf tree, and we have a line feature code for flow line. So every time when we are going to extract some features in TBC, we need to tell TBC what is the feature code or the feature you want to give to that point or line. In each feature code, we could add more attribute fields such as height, trunk, type, and we can add more than one symbols so that trees will always show in this green and round type of symbol. And maybe, as you can see here, I have a pole in this type of symbol. Similar thing happens for these line features. We can define the line style in the feature code library. For example, if I'm not super happy with the default line style attached to flow line, I can right-click on this feature code and choose new attribute to add some other attribute fields. Or if I simply want to change the line style, I can go to its properties and change the line style from here. By default, there's only one solid line attached to TBC, but if you happen to have, say, a Autodesk line style file with you and you want to keep the same styles, you can import that and it will read all the line styles from that file, add all of them to your current library, then you can start to choose from a much wider list. All right, so that's pretty much I'm going to talk about the feature code library so far, and let's jump into extract features. In TBC 530, we enhanced the point feature extraction command a little bit so that now not only we can automatically extract the trees, we can also automatically extract poles and signs. Here is how. Due to the time limit, I'm not going to extract everything from this data set. So I draw a boundary around my point cloud, and today's demo will mainly focus on this area. So I'm going to go to the macros tab first and choose point by boundary. I will pick my boundary and TBC will highlight my point cloud in this boundary area. And now I can go to my point clouds tab, choose keep in. So everything outside of this boundary will be temporarily hidden and they will not be processed or analyzed from the following procedures. And now I'm going to also turn off, say, the poles and signs region and only leave the ground and high vegetation on. And then I'm going into extract point feature. Starting with the tree feature extraction type, we have the manual mode or the automatic mode. With the automatic, who still wants to use manual, right? So I'm going to extract all the tree attributes by clicking one button. And as you can see, there is a progress bar showing up at the bottom of TBC telling us how much longer we still need to wait. In this data set, I believe it's less than 1 minute. And at the same time, we can probably take a look at the command pane together. Usually in TBC's command pane, we try to sort all these buttons or boxes following the chronological order of how you are going to use this command. So for example, here, I will choose the extraction type first, then choose automatic mode, extract tree types. Then I can start to put in the starting from point ID, give all of these points a feature code, and then maybe go through every single one for some individual modifications. So now we have these magenta symbology showing up on these trees, telling us that, hey, I detected all these trees, but if you want to go through all of them, please use this traveling salesman route to access every single tree in case that you may revisit the same tree twice or something like that. How do we utilize it? You can first click on one of these magenta tree, choose the temporary object from the right list, contact list, then mark this tree into this black color. That will tell you this is your beginning point. Then you can use these go to next button to access the next available tree. So let's give it a try. It's jumping to this tree and I can take a closer look and realize that, hey, maybe this is not the tree I want to have. See, there is a false positive tree detected. If I realize that this is not a good result, I'm going to say ignore this tree. Now this tree turns into the red color, telling me it's not going to be added eventually into my data set. So keep going on. This is good. This is good. I'm not going to go through every single tree, but potentially, actually, eventually, you will come back to your previously marked tree to close the loop, and then you should be ready for the next step. Speaking of the feature code, if I now type in BT, you may see these mapped attributes showing up. But at the first time, if you import a brand new project, these fields may shown as unmapped. Why? Because although TBC will detect all these spread or trunk diameters, it will still need to know to which attribute field I should fill these values in. By default, it doesn't know, so it will show as unmapped. So we created this so-called feature attribution map file. You can go to the project setting easily from the top of the command and find this EXL file that shipped with the TBC. It's called feature extraction attribute map. And if I try to open it in Notepad kind of software, you will see what it's basically saying. For, say, this feature code, every time when we return this pole diameter value, put it into this attribute field. So we get this question a lot from customers that, well, I understand you prepared this for your global features FXL. What if I have my own feature code library? The answer is, yeah, once you understand the structure of this file, it will be much easier to just prepare the attribute fields as usual, and then modify the attribute map. And that I'm going to show you how. So now I'm going to first add all these trees. It will tell me 22 trees will be extracted. And as you can see, we have all these trees showing up. Also, you may notice that for these trees, some symbols are larger than others. Why? Because when we designed our feature code library, we actually can control how the symbology's dimension can change or vary based on a field or based on an attribute value. So for example, here, if I open this symbology for the tree, as you can see, the scale of this symbol is associated to this attribute spread. So the bigger the spread is, the bigger the symbol will be, right? And now let's try extract the poles and signs. So the first thing I want to do is to turn off the high vegetation region. Turn back on the poles and signs region. All right, so as you can see, we have some poles and signs in it. I'm going to change my extraction type to pole. Before, remember the automatic button will be grayed out. From TBC 530, we added the automatic mode in. And also, if you want to know what's sitting in these settings, once you choose automatic pole extraction mode, TBC will ask you what will be your minimum pole height. As we all know, usually poles or signs are elevated from the ground, and they can easily be, but there will be so many misguided objects around those things, maybe a fence wall, or maybe it's a mailbox post, something like that. If you want to eliminate those false positive return, you can try to change the minimum pole height from default 1 meter to 2 meter, or in this case, if I just want to extract power poles, not signs, I can change the minimum pole height to 5 meter. So anything shorter than that will be ignored. Can hit OK. And now extract pole attributes. This will also take just less than 1 minute. Maybe we can take this time to check the question board and see if there are any questions. Oh, only one question. Screen's not on yet. Thank you, Dennis. There we go. It's finally moving. there we go. Similar traveling salesman route and similar symbology on top of each pole. And this time I will put in a feature code called pole. And as usual, at the beginning, if this is your own feature code library, you may see this attribute mapping unmapped, right? So I'm going to change them to pole diameter, writing to diameter, height, writing to height. Before I leave this command pane, I can quickly go to the export command and export my own EXL version. Once I save it, next time if I'm going to reuse the same feature code library, I can use this EXL instead of the default one to speed up my feature extraction. All right, so hit add again. And also, if you want to extract some other signs manually, this is how you can do it. For example, this sign was not extracted by TBC automatically. Then I want to add them manually. How do I do that? I can change the point size a little bit so I can see the sign better. And then all I need to do is somewhere on the trunk or the post of the sign and hit enter key or extract sign attribute. And there I got my sign post on. I can type in the same feature code pole. And here I'm going to use diameter, height, and for the type, I may say this is actually a signpost add. All right. So now back into my view, because how I set up my feature code library, some of the power poles are not showing up yet. So let's come back to my list. Oh, I forgot how many of them are actually poles, but let's see. Okay, yeah, so seems good. So from here, I can change the attribute, the type of the pole for all of these points. I can change them to power pole and then compute the project. Now we get all these poles extracted and with the symbol and some labels attached. All right, there are a lot of other type of point features that we want to extract, but they are not available using these manual or automatic mode yet. Then how do we extract them? For example, here I may want to extract a manhole from my road surface. How do I do it? To see the manhole better, I'm going to change the rendering method. Here is my manhole. From TBC 530, I would introduce this cat command line to help you speed up the feature extraction. For here, if I'm going to extract a pole or sorry, a point, I can just type in PO, create a point, enter, give this point an ID. Maybe I will call it 100. And I can type in the feature code. For this case, it will be sanitary manhole. And now I can move my cursor back to my plan view or whatever and click on the point. It will ask me, hey, I detected an elevation. Use it, hit enter to accept that elevation. In this case, I also want to modify the diameter of this pole. As you can see, it's definitely bigger than the actual size. How do I do it? I can go to the measure command in TBC, measure it from one end of the manhole to the other, and Control C, Control V to update the diameter. Notice that the symbol will also shrink a little bit to reflect the diameter. All right, so that's pretty much I'm going to talk about for pole or point extraction. Next, I'm going to jump into line feature extraction, and I'm still going to use these line heavily. So for example, here I want to extract the center line of this road. if I'm not quite familiar with all my all available command line codes, I can type in a question mark and then find all available commands from this drop-down list. In this, I know I'm going to create a line string, so type in L and start point, hit enter, keep adding, and go even longer this way. There we go. When I'm ready to finish my line, I don't have to really do any specific thing, just hit the escape key on your keyboard, then you're ready to start a next line or next command. And I may want to also create some edge of pavement, but before I do that, hey, this is just a line string, it's not a feature yet. As TBC or my other colleagues know, this is a center line. With this line still selected, using the properties pane to assign the correct feature to this line. In this case, it is a center line, so I'm going to choose a line feature called center line for it. As you can tell, the line style has changed. The layer information has been updated as well. All right, let's try one more time. Enter a command. If I'm going to revisit my last used command, I can hit my space bar and it will automatically jump into the line string create. And if I want to create a smooth curve instead of a straight line, and change them here, or type in these highlighted blue text to enter them. Well, this is a quite straight line, so probably you cannot see the smooth curve behavior here, but it is a smooth curve line. And same thing, while this line string is still highlighted, give it the proper, in this case, edge of pavement. And also, yeah, let's try this smooth curve here. I will start a point. And this time I'm going to just change the mode from line to arc and also use smooth curve mode. As you can see, TBC is creating a curve for me right here. For the edge of pavement, it seems like we also have a feature attribute to fill in. What is the surface type? In this case, I know it's asphalt, so I'm going to type that in. I should edit that for my previous line as well. All right. And so using this line string, it's very easy to create polygons, maybe to represent all the buildings. Here, I'm going to change color to true color so we can see the buildings better. Building region and ground region on. And let's select some common buildings from our view. As you can see, there is a big building in the center, and I want to probably create a polygon at the foot of this building to represent this building instead of creating a polygon that has more than one elevation included. How do I do that? So enter a command line called polygon. For the first point, I'm going to just create a point somewhere here. Oh, sorry. Click in my plan view, and right now it's detecting that elevation on my click, but who knows, maybe I clicked a point on the rooftop, but I want to have a elevation from the foot, so I will enter my 3D view plane and somewhere at the foot of this building. Now, as you can tell, I'm looking at the correct starting point. Now, for the following points in this polygon, I can snap to my point cloud points. However, I don't want to use all these random elevations anymore. So I'm going to say, instead of using this elevation, I'm going to use undefined elevation. So TBC will not use that elevation instead. And for these blank space clicking, that's okay. TBC will send back a question mark for elevation. That means we can just accept that elevation. So by doing that, I can create a polygon just using the elevation from my starting point, as you can tell. Okay, so let's give it one more try. Escape to finish your polygon creation, and then space to start another one. This time, maybe we can create a polygon for this house. Let's find them in plan view and 3D view. Same thing for the first point. Do not accept the default elevation. Instead, come to the 3D view and click somewhere at the foot of the building. Oh yeah, there's my point. And now for all the following points, just keep clicking undefined elevation, enter undefined elevation, enter, and keep going this way. If you have used the polygon or line string creation in TBC before using the regular command pane, you will know this method will help you to save a ton of time repeating all these clicks. So there we go. We got one more building done. This time I got two building polygons created, and I want to assign the same feature codes to both of them. How do I do it? I can choose one of the polygon and right click, then say select similar. And TBC will analyze the layer information, the line style information, etc. to, well, maybe I have another polygon sitting in the same layer using the same line style. I would consider them as similar objects. So as you can see, it did a great job finding these two polygons. I'm going to change the feature to building for both of them. Now they share the same line style as other buildings do. Another thing you may notice is for my existing buildings, I also have a label to represent the area or annotate the area of this building. We can do similar thing here. So if I go to drafting, label style manager, I have already created some polygon label style in this manager, telling TBC I always want to label my polygons using the area type. I can add some other labels like parameters or large area in acre or stuff like that. I can control where this label will show, but this time I'm not going to change anything. With this label available, I'm going to now label polygons. Make sure I am still looking at the correct label style, and then multi-select polygons to label. I already have these two selected, so I can easily click Add. Now these buildings also have the same label available. Next thing I want to show you is also about line style, line feature extraction. A lot of the times we see these power lines in our data set, and we want to extract those stack lines quickly from our data set. How do we do that? I'm going to merge my 3D view a little bit and show you the area. Oh, not poles and signs, power lines. And maybe this time the region color rendering would be a better way. As you can see, we have a lot of power lines going along the street. If I want to see them in a clean way, I'm going to create a cutting plane view. But first, I'm going to define a plane manager. telling TBC where do I want to create this cutting plane. In this case, I used the vertical plane method, and I manually picked 2 points from these power lines, 1 point here, and maybe 1 point from the other end of the street. And then I can rotate my 3D view to make sure that potential plane looks all right. Now I can open the cutting plane view. And I can see all my power lines sitting here. Sometimes the default cutting plane thickness is only 2 centimeters. You can thicken the plane a little bit to see all the power lines available. So probably the most important one is the lowest power line, so we can easily calculate the clearance to the ground. For that, first I want to create a best fit line. So go to the CAD tab, best fit line. I'm going to say I want to create a polynomial curve in 3D, and for the selected box, I want to select, using the Polygon select tool, I want to select the bottom power line. After your selection, TBC will start the calculation right away and give you this best fit line and ask you, do you want to apply it? So you will still need to click apply after seeing this red line. And then I can continue going to the next one. Say in this case, maybe I will try this one because there's still some parts missing in between these power lines. And I wonder if TBC can do a great job. There we go. We got another power line created and apply. Maybe we'll create one more over here. This can be another challenging one because there's nothing much left to the left side. So another great job. So I can apply and now close my tab. If I now look at my 3D view and maybe turn off all the point cloud, you will be able to see 3 power lines created. Again, right now, they are just the line strings. TBC does not know they are power lines yet. So choose one of them, select similar, have all 3 selected, give them the proper feature. In this case, I know they are overhead electricity, so I'm going to choose that. There we go. Their line style has changed, or their color has changed, and in the 3D in the plan view, you can see the proper line style showing up. All right, and also you may notice that for some of the previously extracted trees, seems like the label is partially covered by the symbology of this tree. For better visualization, you may want to move these labels a little bit so they don't overlap with each other. How do we do that? Under the drafting tab, you can create a leader line very easily. I'm going to open that command. First, it will ask you for a target label. In our case, is this label. And immediately TBC will start to create this leader line. So we know, okay, maybe I want to put my label somewhere here. Then I can continue, do the same thing, click on the label and move it somewhere else, right? All right, so those are the things I want to cover for point and line extraction. Next, let's try some surface creation. I may have to speed up a little bit. We're running out of time. There are so many things we can talk about in TBC. So turning back on the ground region, and at this time, I'm going to close my other layers. Usually, when we are going to create a surface using the point cloud, you may just select everything and go to the surfaces tab and create a surface from there. I have already defined the limitation of how many point cloud points can be used for surface creation. So I'm not too worried about the performance. All right, so I got this surface created, as you can see. However, for these empty area, maybe blocked by a building or something, TBC will still try to connect all these dots. However, these are not true data, so we probably want to trim down the edge a little bit. If you want to do that for some detailed area, you can use Trim Surface Edge button and choose one point outside of the surface, one point inside of the surface, then that area's edges will be gone. You can only do this in a plan view. But at the same time, you can see we have so many different areas we need to take care of. This might not be the fastest way. Instead, I would recommend going to the surfaces property, change the maximum edge length. By default, we give you a huge number so that we will not miss any edges. But in this, you can see most of our edges should be less than, say, 5 meters or something. So I'm going to change that to 5 meters. And there we go. It's now creating some better surface, but still in certain cases, it's not doing a great job. So sometimes it will be much easier if you already know what kind of surface boundary you want to use. In my case, let me turn back on my boundary layer. You can see I have already created a polyline around this road surface area. I'm going to add this polyline as a boundary to my surface. Surface boundaries, select this one and add. Now TBC trim out everything outside of this boundary. And let's take a look at the result. It's just using the default one solid color, so it's not that easy to see. But as you can see here now, this surface looks more realistic. All right, so once you have the surface created, you can do so many other things. For example, you can drape a texture, such as a Google Earth image or something, to the surface, or you can create contour lines on top of this surface. We probably won't cover all of them in today's session. Now the surface is created. I am going to create a alignment and then a corridor to represent this road. How do I do that? Back in the plan view, actually, I'm looking at all these layers. I'm just going to turn everything back on. All right. So remember, we created this center line earlier. I'm going to use this center line as my alignment and then build a corridor on top of it. I'm going to the corridors tab, create alignment, give it a name. And to define individual segments, I want to use this existing line and click OK. We're not going to edit any definition on this alignment. Instead, I'm going to create a corridor right away. For this corridor, I'm going to call it road. Horizontal and vertical alignment is already selected. Original ground, I'm going to pick this new surface we just created. That will be our existing ground. And then also I'm going to use it as my reference surface. Beginning station, we can usually type in 0 unless you are handling very complex corridor structures. This corridor template editing window will now pop up asking you for instructions. How do you want to create this corridor? The first instruction I'm going to give is using the offset slope type. So starting with our center line, I'm going to create a lane that is about 12 feet white, and the slope is -2%. For this lane, I'm just going to give it a node name, LN. Add. As you can see from this cross-section view, as well as the plan view, we have a right lane created. I will continue this method and create a shoulder. For the offset, it's 3 feet, slope maybe -3%, name shoulder. For these blue and red color, that is basically the cut and fill information comparing to our existing ground surface. The last node, I'm going to create a ditch using the side slope type. That's basically saying, well, I'm not quite sure where my current shoulder node is comparing to my current ground surface. What if it's above the ground? What if it's below the ground? Should I fill more material or should I cut my current ground surface? In this case, we can kind of put in a what if condition. The target surface should be our existing terrain. The cut slope, I'm going to put in a 1:2 ratio. The ditch width, I'm going to say, let's say 1 foot. Oh, actually, this is 1 meter. So I'm going to put 1 SFT. For the fill slope, I'm going to put in a 1:5 ratio. And for the name, I'm going to call it ditch. Add. As you see, at our current station 0, I do need to fill in more material to get to my ditch point. However, if I'm going to slide or move along my corridor, sometimes you will see that, oh, we may need to even cut our road a little bit to get the ditch designed. But right now, we only have the right side of the road designed. How can I quickly replicate the same commands for my left side? Use the mirror instruction icon. And then it will replicate or mirror all the above commands to the left side. As you can see, I don't have to do much over here. And also you can tell in this case, we are actually going to dig into our current terrain to create this shoulder and ditch point. All right, so with the corridor designed, I can now do even more things. For example, I can choose this horizontal alignment icon and turn back on my point cloud, maybe change the rendering to true color and go to corridors tab, enter 3D drive view. In this 3D drive view, TBC will follow this alignment and you can change the drive speed and move along the street as you want to. And while you're moving along the road, you can also look around, talking about a virtual tour. So in this case, maybe I want to add another point to represent this trash bin. I can quickly go to, remember, cat command line, PO, point ID 101 is okay. In this case, I don't want to enter any feature code and just tap in a point. And let's zoom in a little bit. There is our point sitting on the trash can. Yeah, so that is the 3D drive view once you have the corridor created. Next thing, and probably an also very important thing, is the export. As you may know, TBC store all the exporters mainly from this export command. For all the mobile mapping options, specifically if you need to export MX9 trajectory, imagery, and point clouds into a third-party mobile mapping processing packages, you can go to this mobile mapping tab and choose export to Soft3D, TMX, Trimble MX, or TopoDot. they will give you different options to prepare our data set in the desired formats. If you are mainly interested in exporting the point cloud, you can use the point cloud tab. And here, LAS, E57, and other industry standard formats are all available. We recently get this question, thank you, Kat, that sometimes you may have created your own region, for example, a car region to host all the cars. Then how can you reserve that classification while you're exporting the point cloud? So one thing that's good to know is every time when you have a point cloud region created, TBC will give it a classification code. For all these default regions TBC create, we follow the standard ASPRS LiDAR point class codes. So 2 is always ground, and 6 is always buildings or construction stuff. When you create your own region, by default, TBC will only assign a code 0 to that class or region. All you need to do is to type in a number anywhere between 66 to 255. Those are customizable codes based on the ASPRS definition. So once you have that code in, you will be able to export that region as an individual class, right? And also for other CAD formats, say we have created all these surfaces or line work and points. What if I want to bring them into Autodesk or MicroStation? Right now, we only support DWG and DXF formats, but at the same time, we also support, say, the land XML file format. If you go to the construction tab, this is a very popular file format that's supported by MicroStation and Autodesk. It's super handy for these corridor or surface kind of structures. The only exception I probably won't use this export command for is the GIS. If you're just looking for KML or KMZ type of export, then of course this is your go-to place. But if you want to just push these points or features into an existing GIS geodatabase or shapefile, I would recommend going through the GIS tab. Connect to your GIS data source. In this case, I'm going to choose File Geodatabase and choose a GDB sitting on my computer. Of course, Enterprise Geodatabase is supported as well. And then I can write these features to this GIS file data source. So I'm going to choose all of my points here. Notice that I can select everything. I don't have to specifically pick all the features. And here in this list, TBC will understand only 22 broadleaf trees are detected, or only one center line has been detected. All the point clouds or other surface information will be automatically skipped. And I can now click OK to finish the writing. And there we go. I already finished all these features from a previous practice. And now if I refresh the view, there we go. We see all these new features popping up. And in this case, I don't have to handle duplicated geodatabase or data files. Yeah, those are basically all the things I want to cover. Let's jump back into the presentation. Yeah, so yeah, I guess we have a few minutes left for the Q&A. Sophie, do you see any questions standing out from the panel? I see some red flags.
Yeah, there's definitely quite a few questions here. I don't know which one you want to start with. One question that came up twice is, I think generally what accuracy or noise level is needed for the feature extraction to work. This came up once or twice. So if there's
well, actually,
like,
we don't. Yeah. So for I suppose you're basically asking for the accuracy from the MX9 hardware, because from the TBC standpoint, or how you collect that data, a data set is a data set. It can come from the very precise MX9 LiDAR laser head. It can come from, say, a mapping GIS grade handheld data collection. TBC does not judge the accuracy of the data set. As long as it is a data format TBC understands, then we can apply the exact same workflows we showed today. Oh, I see. Okay, so probably for the feature extraction you're talking about is the point extraction, the trees and poles command. Yeah, I think now I understand your question. Yeah, so for that command, we actually recommend you to go through the point cloud classification first, because that will help TBC to filter out some unnecessary noise in the point cloud and really focus on the good data over there. Overall, we are basically analyzing the intensity, also the structure of the point cloud comparing to its surrounding environment. So for those trees, as you can see, sometimes they grow in any kind of direction they want to. So maybe the accuracy or the noise level is high, but still TBC will be able to detect something. But again, keep in mind that this is an automatic algorithm. It will always have some error happening in it. There's no way we can deliver 100% accurate results.
Okay, perfect. And I think a question you've already answered a bit further into your presentation is, that was a question that came early, whether it's possible to export codes with attributes into any 2D drawing platform like AutoCAD.
Yeah, that is a good question. Yeah, indeed, we could deliver these features, or not this one, these features into Autodesk. And also, if you notice, when you choose DWG exporter, we actually allow you to export the attributes together with these features. So for those trunk diameter or spread diameters, you will be able to access them still in Trimble Access, in Civil 3D.
Okay. I don't know if there's, I think these were the kind of the main questions. Anything else? I think we'll follow up afterwards if anyone has an urgent question that they want to put in. Okay, so someone just asked what's our experience with the rate of false positive or missing elements in the automated extraction?
That is a good question. So far, while I don't have the overall numbers, I don't think we have that number anywhere, because it's really depending on the data set you have. Sometimes if you only have very sparse point cloud in a data set, that could impact the detection rate ratio of this algorithm. Or sometimes simply because you scanned only half side of the tree, then TBC will still give you some result, but the position of those trees or poles can be quite off from where it is supposed to be. But in this data set specifically, I would say maybe the accuracy ratio is about 85% or so to me. I don't have to do too many manual modification afterwards.
Okay, perfect. I think that's it. I think we're out of time as well. So anything we haven't answered, we'll follow up by email. Thank you.